Alrighty, so this should be chapter 32, which is handling mirrors. I'm gonna start with this problem just because it's like two flat mirrors. And if you recall, when you have a flat mirror, you have also the law of reflection, where the angle of reflection is the same as the angle of incidence. So the reflection would be the light coming out, and the incidence is the light coming in. Cool. And then that's the law of reflection. So in this problem, we have the light coming in here and then bouncing down onto this mirror. Both of these long arms are flat mirrors, and then the little ones are the light coming in and going out. So then that's our light coming in and out. We are given the first angle, A, which is 38. And then based on our law of reflection, we know that B must be the same, which means that B should also be 38 degrees, right? We also know that the two mirrors are at a 90-degree angle. We know that triangle, all three angles should add up to 180. So in this case, we have B plus the 90 degrees plus C should all equal to 180 degrees. We know that B was the same as A, so 38 degrees. Which those two will combine to get us. Sorry, I'm grabbing my calculator. 120. No, 128. And then we can move that over there. Which should get us 80 minus 52 degrees. So we know that C is equal to 52 just based on the like this triangle here. This triangle here. That the light's making with the two mirrors. So you know that one's 52 degrees. And then we're asked for D, which is kind of between the reflection light and like this imaginary perpendicular line here. And the way I would do this is I would go back to the law of reflection. Okay, if C's coming in here and going out that way, then that means that these two are the same. Which means that this angle here is 52, right? And then because that's 52 and this larger angle is 90, then we can just go 90 degrees minus 52. Minus 52. which gets us 38 degrees. That's D. So D is equal to 38 degrees. And that's pretty much it for that problem. We also have another problem over here where we have a concave mirror. So me use white. We have a concave mirror, right? So when you're thinking of mirrors, you can have concave. No, no. I mean, I can't write up there. Okay. Have concave, which is like this, and you have your negative sign, and you're gonna have a positive frequency, I think. No, it's not frequency. Focal. Or you have convex, which are like this, where this is your this is the side that you're looking at, and you're gonna have a negative focal point. Right? And for the concave, we have like it over here, right? And for the convex, it's kind of like bouncing out. And then, yeah. Let's take down, because I'm going to definitely need more space than what this is allowing me to do. So we have half centimeter height, 2 centimeters mirror, and R is equal to 3 centimeters. 1 second. My parents just got home. Pause it. Okay, sorry about that. I'm back now. I believe I should still be unmuted. Yeah, I am. Cool. One thing I forgot to mention is that it's convex. It's negative because the focal point is behind the mirror, and that's why you have a negative focal point. Whereas this one, it's in front of mirror. Anyway, let me go ahead and grab this and move it to another page. Let me see that, can you? Do this. I guess you can see it well enough. Just right over it. Cool. So then we can go ahead and draw our mirror. Something like that, probably. And then we know our R is 3 centimeters, and we can find our focal point by doing focal point is equal to r over 2, which is equal to 3 over 2, which I believe is 1.5 centimeters. We can also add our object, so let's do that. Back. How well does this? Oh, it has. So we'll start that at the mirror there. Then we have our object, 2 centimeters in front of it, right? Yeah. I know that's technically here, but I kind of want more space to draw stuff. So I'm gonna do double scale, just so that it's not as tiny. So instead of 2, we'll have it at 4. And then object is, it's 0.5 centimeters, but because I'm doubled the other scale, I'm gonna double this scale as well. So there's our object. And I believe we can denote that this is our object by going, we just say it's like O for object. Okay. From here, we're probably gonna need this equation as well. Write it. Our focal point is equal to 1 over d naught plus 1 over the initial. Okay. And then, can we plug these in yet? Let's see, we have focal point, and we have our d naught, I believe. Let's draw it in. Two centimeters. And I'm pretty sure this is your D naught. The knot always throws me off because like I'm saying it's not because that's what I'm used to, but it's actually object. So yes, that should be our D object. It's not D naught as an initial, it's the object. Okay, so then yeah, so we have that one and we have that one. So we can go ahead and calculate then. Probably moving this one over. So 1 over minus 1 over D object is equal to 1 over DI. Which that's going to become DI is equal to 1 over. We'll just plug it in first, and then we'll do the inversion factor. Point was 1.5 centimeters. And then this was 2 centimeters. Yeah. 5 minus 0.166. I'm gonna stop at 7 just because that's where we are, but you would probably want to use the entire value when you do your inversion. And then we'll do 1 divided by that. I got 6 centimeters. When I say inverse, I just mean that it's gonna be like this: di is equal to 1 over your fraction. Cool. Then we also note that this is positive. Which means that it's in front of the mirror. It also means that it's a real image. As in, like, if you were looking at the mirror, you could actually see it. Move these down. Or at least over here. Because I know we're gonna need the space over here for the drawings. Alright, cool. Also note that our focal point is positive, which means that it's in front of the mirror, which we already knew because it was a convex. I think I'm gonna go ahead and finish the calculations before we draw the rays. Anyway, so now we have our DI, which means we can calculate for our M. And the equation for that one is, it's either M is equal to HI HO, or M is equal to negative DI over DO. Because we have our D's already, like that's what I'm gonna use. You could probably use the H's if you really wanted to, but it would be easier to use the DI's and then use your M to calculate for your new H's. So we'll do that. M is equal to negative DI over DO. Go ahead and plug that in. M is equal to negative 6 centimeters over your DO, which is 2. I believe that's just going to get you negative 3 centimeters. Because your M is negative, you know that it's an inverted image. And then we can use this to calculate our H. Then we have our M is equal to HI over HO. We have our HO above. Should I remember it being 0.5? Yeah, so that's our HO. So this can become MHO is equal to HI. Let me go ahead and plug that in. HI is equal to, we got -3 centimeters. And then that was 0.5 centimeters. Which gets us our HI of 3 times 0.5. It's 3 divided by 2. It's -1.5 centimeters. Because we have a negative here, it means that our image is inverted. Cool. So then let's see. The question itself was asking for position. Let me a different color. Okay. So this is what the problem is quite asking for. And then we found that, I don't know if we found the position just yet. I mean, it would probably be the HI. I'm gonna draw it first just to confirm. Size D. Okay, D we already know. We know that it's inverted because both of these confirm that. And then the positive sign in front of the D shows that it's a real image because it's in front of the mirror. So real. Size of the image and position of the image. Size of the image, I'm pretty sure is the HI. So it's the 1.5 centimeters. And then the position of the image would be D because that's the distance. So that's going to be the 6 centimeters. Cool. I know I always say I and not for these because like for other velocity and stuff, you use 0 as not and I as initial. But for like lenses and stuff, it's usually O for object and I for image. So this is DI, this is HI. And then these two are via signs. And the last thing that the problem asks for is to draw the ray diagram. When you're drawing ray diagrams, you follow the like little diagram that she always puts on the screen where you've got like that eye looking down at it. I'm sure you know which one. She tends to use the same image from the textbooks for all of them. Anyway, for this one, we start with where our O is. I will draw with the pink. We're gonna need a ruler. Make sure you bring a ruler on the exam. Like that will be absolutely necessary. Okay. Anyway, start with our object. We're probably gonna have our object prime, which is usually up. So let's just draw it here. We're gonna go straight. Make sure this is at 0. Yeah, it's at 0. Okay. You know what? Let me draw it slightly higher so we can follow the line there a little bit. You know what? Let me draw the focal point first. Focal point is 1.5 centimeters. And because I doubled the scale, that means that it's 3 centimeters. So here's your focal point. You have this light coming out here. And then from the mirror, it has to go through the focal point. So start back here, then goes through the focal point. So that's one ray. Then the second ray is starting again from your object prime. This time it has to go through the focal point first, and then it has to go straight out the mirror. So let's line this up so it goes through both. So it goes from the object through the focal point, and then it goes straight out the mirror. This one, there we go. It looks like I need to draw this line a little longer. Draw this a little bit longer. There we go. And then for our third ray, anyway, sorry about that. I didn't realize that the recording or the video had stopped. Anyway, we had just drawn our two incident lines. One starting from the object and then going straight to the mirror and then through the focal point. And then the second one that goes from the object through the focal point and then out the mirror. I seem to remember her saying that those two were the most important ones and that she wouldn't always check for the third one. But I'm gonna go ahead and try and do the third one anyway. I remember it like looks at the center of curvature, which I don't think it's the same as radius, but it's probably related. If she told you of a better way to do it her way, but this is how I remember doing it. I remember going from where these two meet through the object or the object prime. And sometimes you didn't draw your mirror large enough, so you might have to expand your mirror. But But yeah, I think I'm definitely gonna have to expand my mirror. And then this line here would probably be your center of curvature, where it like goes through this middle. Cool. Let me expand my mirror out a little bit. Try to move these. Granted, this is not a very smooth curve, but yeah. And then theoretically, I'm pretty sure this third ray is supposed to be perpendicular to the mirror. So I'll try and make it look perpendicular. But I'm pretty sure she's gonna have you guys focus most on this first ray that you draw, and then the second ray. But yeah, that's all for that problem. Pretty sure. And I think the last thing I wanted to do was, let me draw one here. Go through like the little signs and stuff. Okay. So this is what I have in my notes. We have distance, which is denoted by D. From here, we have our D naught, and we have our DI. Where O is for object, and I is for image. And then from here, they can be either positive or negative. Here, positive or negative. If you have a D object that's positive, that means that it's left of the mirror or in front of. And then again, right or behind. And then that's the same thing for the D image. If you have a positive D image, you have it left or in front of the mirror. And if you have it negative, you're gonna have it right or behind the mirror. Also note that she's not gonna be mean and give you this. Because that would mean it's a virtual image or a virtual object. So it's theoretically possible, but she's not going to give it to you. And then all of these are of the mirror. And these two are for the image. And that one's for the object. And then the other two are a bit easier because then you just have your focal point. Which is your F. It's positive. Then you have a concave mirror. Right where it looks like this. I'll put a little dot there. Or it looks like that. Remember, this is where we drew like the light. If it is concave, and that means that your focal point is positive, then you have it in front of your mirror. So focal point. Left and in front, or right and behind. So let me go ahead and copy and paste that. And finally, you have your M. Does it have space on here? And squeeze it in. Which is, I believe, your magnification. So again, that can be positive or negative. If it's positive, then that means you have an upright image. If it's negative, that means you have an inverted image. And what that would look like is if I were to draw something, let's say a tree. If I were to draw a tree and it was upright, it'd look like this, right? If it was inverted, it'd look upside down. Apparently not good at drawing a tree upside down. But yeah. I guess I should probably turn this. There we go. Cool. And that's all I have for you today. Thank you for coming or watching. But yeah. Bye.